Namaskar. I am Sandeep Chaudhari, working as Assistant Professor in Department of Electrical Engineering, All India Shri Shivaji Memorial Society's Institute of Information Technology, AI SSMS IOIT, Pune. This presentation is about comparison between permanent magnet moving coil, that is PMMC instrument, and moving iron instrument. This shows the comparison table. Point by point, the comparison will be elaborated. So first point is suitability. The PMMC or moving coil instrument is suitable for DC only. As we know, it works on current carrying conductor placed in magnetic field experiences of force. So for AC quantities, unidirectional torque is not possible. So PMMC cannot function for AC quantities. So its suitability is for DC only. Whereas moving iron instrument, since the working is based on either magnetic attraction and repulsion, and both effects are present in AC as well as DC, this instrument can function for AC as well as DC. So suitability, PMMC DC only, and moving iron for both AC as well as DC. Next point, torque to weight ratio. Torque means the torque produced on moving system, and weight means the weight of the moving system. For PMMC instrument, the operating magnetic field is very strong due to permanent magnets, NS poles, and the moving system weight is less. It is just made up of aluminum former and a very delicate copper coil. So weight of the moving system is very less, and that is how the torque to weight ratio, if we work out, it is quite high for a PMMC instrument. For moving iron instrument, the weight of moving system is bit at a higher side compared to PMMC. That's why the torque to weight ratio is less compared to PMMC instrument. Next, damping. The damping in case of PMMC instrument is achieved by eddy current damping method. As we know in constructional details, the PMMC instrument consists of aluminum former on which coil is mounted. So the aluminum former itself gives damping torque. So eddy currents are induced in the aluminum former and damping torque is achieved. And in case of moving iron instrument, you have to have some attachment to the moving system and provide the damping, which is air friction damping. Power consumption is less for PMMC instrument because the power loss in the coil itself is very small. The coil is made up of very thin conductor, so power loss in the coil is very less. In case of moving iron instrument, it is quite high compared to PMMC instrument. Next point, scale of the meter. As we know, the torque equation or equation of deflection, theta is proportional to I, which is current in the coil for PMMC instrument. So it is a linear relationship, where in case of moving iron instrument, theta is proportional to I square. Because of this, the scale is uniform in case of PMMC instrument, and for moving iron instrument, scale is not uniform. Now talking about the moving parts. For PMMC instrument, the assembly and the parts are quite delicate because you have got iron cylinder, aluminum former, a coil. So the moving system itself is quite delicate and it is small in dimensions. So the assembly work, the manufacturing, the delicacy factor increases its cost. Whereas in case of moving iron instrument, we have just got a one iron piece which is kept in the vicinity of coil. So it's a quite simple arrangement. So cost is less. Next, deflection. Deflection is proportional to current only, as elaborated earlier for PMMC instrument, and for moving iron instrument it is proportional to I square. And again, because of this reason, the scale is uniform for PMMC instrument and scale is not uniform for moving iron instrument. Next point, hysteresis loss. Moving iron instrument, it is free from hysteresis loss because the direction of flux is constant, and for moving iron instrument these losses are present because in case of AC the magnetic flux direction is going to alter and the hysteresis loss is going to take place. Next point, error due to stray magnetic field. It is negligible in case of PMMC because of strong operating magnetic field. For moving iron instrument, however, the stray magnetic field may cause a bit of more interference in the operating magnetic field of the instrument. Robustness. The PMMC instrument is quite delicate, so it is not mechanically strong. It cannot sustain mechanical vibrations or mechanical shocks. The moving system may be damaged due to the vibrations, so it is not robust. Whereas moving iron instrument is robust, the coil is a stationary member and iron piece is also that way considered as comparatively better uh, arrangement or better moving system when we talk about the robustness. Next, life or aging effect. The strength of magnetic poles is reduced due to aging effect, whereas the aging effect for moving iron instrument is not present or you can just neglect it. It does not use any permanent magnets. Cost. Due to delicate assembly and small parts in moving iron instruments, the cost is more. Moving iron instrument, the cost is less because of ease of assembly and the parts which are used, they have less cost. Next, effect of frequency. Since the PMMC is used for DC, the frequency issue is not there. However, for a moving iron instrument, the frequency issue is present. So when you design an instrument, it is suitable for that frequency only and that nature of waveform. So if you design instrument for 50 Hz sinusoidal waveform, you cannot use it for triangular 50 Hz or square wave 50 Hz. You have to design it separately. And in the similar way, magnitude wise also, you cannot use the 50 Hz instrument for 100 Hz or 25 Hz. Temperature effect is negligible for PMMC instrument. For moving iron instrument, the temperature effect causes increase in resistance of the coil. The permeability of the system, magnetic system, is also affected, and the spring stiffness is also affected. However, this stiffness effect is also there in PMMC instrument, but all these three presents are effects are present in moving iron instrument. Last point, which is a moving member and which is a stationary member. Now for PMMC, the current carrying conductor placed in magnetic field experiences a force. So that conductor is a moving member, the coil is a moving member, and permanent magnet is stationary. In case of moving iron instrument, the moving member is iron piece. In case of attraction type instrument, we have got oval shaped iron piece which gets attracted towards the coil. And in case of repulsion type instrument, if you remember, you have got one moving vane placed on the spindle. So moving member is iron piece, a stationary member is coil. So the part which carries current is a coil, and coil is moving member in case of PMMC instrument, and is a stationary member for moving iron instruments. So this is all about the comparison between permanent magnet moving coil and moving iron instrument. Thank you. For more information, you can log on to www.aissmsiot.org.